In this problem, I'm going to use the law of sines to find angle B. So I'm going to use this given information. And so I know that angle A is 39 degrees, and I know side A. So I'm going to go ahead and start with that. The sine of 39.5712 degrees divided by the side across from it, 6, will be equal to the sine of the angle that we're looking for, angle B, divided by the side across from it, so that will be 3. From here we're going to cross multiply, and so we will have 6 times the sine of angle B equal to 3 times the sine of this 39 degree angle. To get the sine of B alone, we're going to have to divide both sides by 6. So I'll go ahead and do that in our calculator now. So 3 times the sine of the 39.5712. Oops, I need to redo that. From here, I'll divide this answer by 6. And so I end up getting 0.3185 roughly. Next, to find an angle, I'm going to take the inverse of this ratio. And I will end up getting angle B to be approximately 18.5733. And that is degrees. Now, it just so worked out that this angle is correct. However, anytime you use the law of sines to find a missing angle, you're running the risk that this answer is going to be wrong. And so we're going to look at that in the next example on how sometimes the law of sines does give us an incorrect answer. All right, so in this problem, it's the same triangle, but now I'm going to go searching for angle C. So I'm going to set up the law of sines, sine of the angle that we know, that's angle A, 39.5712 degrees, all divided by the side across from it, which is 6. We're going to set that equal to the sine of the angle that we're searching for, angle C, divided by the side across from it, which is 8. Again, we'll cross multiply. When you get sine of C alone, it will end up being 8 times the sine of this 39 degree angle divided by 6. And keep in mind, we're going to take the inverse of this. So I'm going to go ahead and type that entire thing into my calculator. So sine inverse of 8 of 39.5712. Make sure that you close the parentheses around that angle. Then you can go ahead and divide by 6. And so what I end up getting for angle C is 58.145 degrees. Now if you look at this triangle, side 8 is the longest side. That means that angle C needs to be the largest angle. Well, if C is only 58 degrees and angle A is 39 degrees, the largest angle would end up being angle B, which we know that that can't be correct. So the problem with taking the sine inverse or using law of sines to find an angle is if your angle is meant to be obtuse, sine will not tell you that. So if you think back to when we were looking at sine inverse functions, sine wanted to be a function, and to make sine a function, we had to define it between -90 and +90. Which means that sine inverse will only give us answers between 0 and 90. So if the answer is supposed to be obtuse, we won't know that. We're going to reject this answer, but we can use it to find the correct answer. And so I know that sine is going to be positive in the first quadrant, which this is that 58.145 degrees. But it will also be positive in a second quadrant, and that's the angle that sine inverse doesn't give us. And so to find this angle, we can take 180 minus this reference angle. Keep in mind this is a rounded angle, so to find the actual angle for C, I'm going to take 180 minus this entire answer. And so I will end up getting 121.855 degrees. And this is the correct answer. So you can use the law of sines to find an angle, but you do need to be careful because if it's obtuse, it won't give you that answer. Law of cosines would probably be a little bit more reliable here, but law of sines does work. In the previous example, this answer was correct because angle B had to be acute anyways. And so if your answer is supposed to be acute, law of sines works perfectly. It's just when we're looking for an obtuse answer.